Hello to all my viewers, this is Dr. Dhaval Maheta, and today I will explain how to do the prediction for a new dataset in probabilistic neural network in KNIME. A probabilistic neural network is a type of artificial neural network that is used for classification and pattern recognition tasks. PNNs are based on the Bayes theorem of probability and they work by estimating the probability distribution of the input data. PNN consists of four layers: an input layer, a pattern layer, a summation layer, and the output layer. The input layer receives the data and the pattern layer converts it into the probability density function. By calculating the distance between the input data and the prototypes in the pattern layer, the summation layer combines the PDFs, that is the probability density functions, and calculates the posterior probabilities, which are then passed to the output layer for the classification. PNNs have several advantages over other types of neural networks, such as their ability to handle non-linearly separable data, their fast training time, and their ability to classify data with high accuracy. However, they are not as widely used as other types of neural networks because they can be computationally expensive and they require a large amount of memory to store the prototypes. Now let's see how we can do the prediction for a new dataset in KNIME. So first of all, we'll activate the input output node from here. Then we'll double click on it. We'll browse. Then I'll activate this data file which is in CSV format. Okay, right click on it and execute. Again, right click on it and see the file table. So it consists of many variables. We require few of them, and that's the reason we'll activate the column filter. We want to predict the heart disease based on age, resting blood pressure, cholesterol, and maximum hours of exercise. So I'll activate the column filter from here. I'll right click on it and configure. I'll take all the variables on the left hand side. I'll transfer age and resting blood pressure, cholesterol, maximum hours of exercise, and heart disease. Click OK. Right click on it and execute. Now, as all these variables are on different scale, it is necessary to normalize it, and therefore we will activate the normalizer from here. Double click on it. Right click on it and configure. Three types of normalization are available. Normally, we go for mean max normalization. Click OK. Right click on it and execute. Again, right click on it and you can have a normalized table. So it consists of age, resting blood pressure, cholesterol, maximum hours of exercise, and all are having the range between 0 and 1. Now I will activate the partitioning of the data so that the data can be splitted into training and testing purpose. Right click, configure, activate 80%. 80% will be used for training and 20% will be used for testing. Activate the stratified sampling, click OK, right click on it and execute. Now, activate the PNN learner. So, this PNN learner will get 80% of its learning from this node. Right click on it, configure. Make sure that the target column is a heart disease, click OK. Right click on it and execute. Now, activate the PNN predictor. I'll have to delete one of them, no problem. I'll disconnect this line and the connection will be established with this partitioning. So the 20% of the data will be fed in the PNN predictor. Right click on it and execute. Again, right click on it and see the predicted data. So this is the prediction done according to the algorithm. And this is the original data set. We want to see how well our algorithm fits to the data. So we will activate the scorer from here. Right click on it, configure, activate the hard disk, the original data, and we are comparing with the predicted hard disk, predicted hard disks. Right click on it and execute. Again, right click on it and you will be able to get the confusion matrix. I've already explained in all my previous video that how to interpret the confusion matrix. So 42 plus 85 are the correctly classified cases. You can see here 127. The classification accuracy is 69% of this algorithm, which is quite low. Now we want to do the prediction for the new data set. So simply just copy these three nodes from here, copy, Control V, and you can bring these nodes here, double click on it, and this time I will save, I'll change the data set. I'll connect Heart1 test. This is a completely new data set which we are going to use in this algorithm. Activate it. So column filter, normalizer, same as usual. Now this data set will get its learning from this node, and you will have to copy this predictor also. So I'll copy the predictor here. I'll connect this here. No. You will have to connect the data set here, and it will get its learning from here, right? So this predictor will get its learning from PNN learner, and the data set will be from here. And right click on it and execute. Again, right click on it and see the predicted data. So this is the prediction done according to the algorithm, and this is the original data. So you can copy this now and configure. Same, right click on it and execute. Again, right click on it and you can see the confusion matrix. So only 3 classifications are correct. Let us check here in the column filter. Configure. Everything is fine. Let us check in normalizer. This is also okay. And in PNN predictor, it's fine. And we will see the confusion matrix. Yeah. So the classification accuracy has drastically gone down. So PNN algorithm is not, you can say, not a better fit or not a better algorithm for this data, because classification accuracy is just 30%. But this is a way you can do the prediction for the new data set in using PNN algorithm in KNIME. For more videos on KNIME, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos on KNIME.